this video, I'd like to wrap up our talk about data structures. We've talked about some really important data structures so far. One of them is the vector, which uses a contiguous block of memory to store all of the information. Each one of the elements within it is side by side, and it has some sort of interesting internal mechanics in order to sort of allow this thing to dynamically grow and shrink, as well as when to allocate new memory and to free that memory back to the operating system in order to be used elsewhere. And there's some downsides to this thing. We know that it requires copying it to another location in memory. Adding new elements at the very beginning causes elements to shift and sort of cascade. And what might seem like a very simple insert may actually be relatively complex, as it's moving all of this data in memory to account for that new value. One of the other important ones that we've talked about, another important data structure, is the linked list. The linked list sort of does what the vector can't do well. The linked list is comprised of individual nodes that look something like this, scattered throughout memory in various locations. Now, a linked list is great in all the aspects where a vector is not. We can very quickly insert a new element here at the very beginning, do it again, and it doesn't require shifting any of the other data. This is still dynamically allocated, so we can increase the size of this thing, shrink it if we need to in the future as well. And it actually isn't consuming as much data as well. Notice how our vector is taking up a bunch more memory when in reality there's nothing being stored here. So it's just taking up extra space. Whereas our linked list is nice and efficient, only has the individual elements. But it is also storing a little bit of extra data. Remember that each one of these elements is actually storing the pointer to the next location. So there's a little bit of extra data stored along with each one of the elements that we have. Now, one of the unfortunate parts about the linked list is the subscript operator, accessing elements. Typically, a linked list only stores a pointer to the very first element. So when we want to access an element that's somewhere later on through the list, we kind of need to iterate and work our way down this chain of elements throughout memory until we find the one that we're looking for. Whereas the vector, even though it's still storing the pointer to the position at the very beginning, if we know which element we want, we can just do some very quick pointer arithmetic. Say, well, we want to move over 5 spaces. Well, what's that? It's here. Boom. We're done, right? If this is at space 0, this one's at space 5, obviously. So it's really quick. Vectors and linked lists, these strategies of a large contiguous block of memory versus individual small elements that sort of get chained together, these strategies are used for almost every single data structure that you'll encounter. Future data structures that you'll see include queues and stacks. They will include trees and graphs. And all of these data structures are built on top of these two fundamental differences, whether or not it's a contiguous block of memory or broken up with individual elements. Understanding these two important data structures is key to understanding all of the data structures that you will encounter when you're programming. And understanding the performance differences about the various aspects of these data structures is key to writing efficient and quick algorithms.